So now we're just going to get a little bit longer. Notice that now we have some exponents that are odd. If our exponents are odd, what we're going to do is factor out one of the variables, which will leave me an exponent that's even that I can simplify. So what I'm going to do with number 16, first of all, is my 50 is not a perfect square. I want to factor 50. What's the biggest perfect square that divides into 50? 25. So I'm going to make 50 25 times 2. That's the same thing we've been doing. Now here's the new part. We have an s to the 5th power. Since it has an odd exponent, we're going to take 1 out and we're going to factor it into s times s to the 4th power. Now the t to the 12th has an even exponent. That's what we want, so we're going to leave that one alone. Now we're going to take out all of our perfect squares. So the square root of 25 is 5. I can't do the 2, I can't do the plain s, but I can do the s to the 4th. What's the square root of s to the 4th? S to the 2nd. And I can do the square root of t to the 12th. The t to the 12th would be t to the 6th. So underneath my radical sign, underneath that square root, I'm going to have a 2 and an s left over. So 5s squared t to the 6th square root of 2s is what your answer is going to be. So anytime you have an odd exponent, you're always going to end up with that extra variable inside because it wasn't a perfect square. So number 17, 27. 27 is not a perfect square. I want to factor 27 into what? Nine, exactly. 25 doesn't work, 16 doesn't work, but 9 goes into 27. 9 times 3 is 27. T to the 6th. Should we leave it alone or should we factor it?
Leave it alone.
Leave it alone because it's already even. U to the 11th. Should we leave it alone or should we factor it? Factor it, and what should we factor it into? U times u to the 10th. I always just take 1 out, which is going to leave me an even number. Now I got to take out my square roots. What can I take out of there? Square root of 9 is 3. Square root of t to the 6th would be t to the 3rd. Square root of u to the 10th is u to the 5th. And what do I have left under my square root? A 3 and a u. So 3t to the 3rd, u to the 5th, times the square root of 3u is my answer. Number 18, that must be the last one on the page, huh? Number 18, looking at 54. 54 is not a perfect square. It's not one of my numbers on my list, but I bet I can factor it. What should I divide into 54? Is 6 a perfect square?
3. No? Well, 9 times 6.
Ah, I like the 9 answer better than the 6
Oh.
answer because 9 is my perfect square. It happens to be 9 times 6 being 54.
Well, see, that confuses me.
So when you look here, I'm doing 54. 64 doesn't work. 49 wouldn't, 36 wouldn't, 25 wouldn't, 16 wouldn't, but 9 does, right? 9's on my list of perfect squares. 9 times 6, 54. The x to the third, do we need to factor that one?
Yep.
Yep, what do we factor it into?
X.
X and
X3.
X 2.
Oh, 2.
Right, if I take 1 out, I've got 2 left over. 1 plus 2 is 3. How about the w to the 7th?
Yep.
Should I do with that one?
3w6.
Exactly, w and w to the 6th. So now that I got it all factored out, now I can take out my square roots. What am I going to take out?
Your 9.
Square root of 9 is?
3.
3, yep.
We'll need the x2.
The square root of x2 would be?
x1.
x1, so just an x, exactly. Square root of x squared is x.
And then your w6.
W to the 6th, the square root of w to the 6th.
5. Oh, 3.
3.
3.
And I have what left underneath my radical?
6x.
6x. So we get 3xw cubed square root of 6x.
What about the other W?
Oops, gosh, what about that other w? I gotta put that one too. W. I forgot that one. Good thing Joel's paying attention. So, since both of these were odd, they both had a variable left over underneath my radical. Alrighty.